Hey everyone, and welcome back. Today, we're diving deep into something you probably interact with dozens, if not hundreds of times a day: notifications. We're going to design a system from the ground up that can handle push, SMS, and email notifications at a massive scale.
So, your phone buzzes. You glance at it, and then you move on. But have you ever stopped to think about the incredible journey that single alert just took? How does a server send that one message to potentially millions of different devices instantly and make sure it actually gets there? Well, that is the exact challenge we're going to break down today.
All right, here's our roadmap. We'll start with a really simple but very flawed first attempt to see why it breaks. Then we'll introduce the hero of our story, asynchronous queues. From there, we'll figure out how to send one message to many channels, give users control over what they receive, and finally, we'll put all the pieces together to build our final super scalable system. Let's get into it.
Okay, so first up, let's look at our V1 approach. Every complex system starts with a simple idea. And honestly, the best way to learn how to build something right is to first understand all the ways it can go wrong. So in our first draft, the process is super straightforward. A service decides to send a notification. It makes a direct call to Apple's push notification service, or APNS, and then it waits. Once that's done, it calls Google's Firebase Cloud Messaging, FCM, and it waits again. Then it hits up an SMS gateway, and guess what? It waits. You see the problem here, right? Every single step is blocking the next one. It's just a long line of waiting. And what do you think happens when you get a flood of requests? Maybe thousands of people get a message at the same time? Exactly. System overload. The whole thing just grinds to a halt because it's spending all of its time and resources just waiting for these external services to respond. It's a recipe for disaster. It just doesn't scale. And this brings us to a really crucial concept in system design: synchronous versus asynchronous communication. Synchronous is like making a phone call. You ask a question and you literally have to wait on the line for the other person to answer before you can do anything else. It blocks you. But asynchronous? That's like sending a text message. You fire it off and then you can immediately put your phone away and do something else. It's fire and forget. This one idea is the key to solving our entire problem.
So this brings us to the real hero of our system design, asynchronous queues. This is the magic component that lets us break free from that synchronous trap and truly decouple our services.
So what on earth is a message queue? Well, think of it like a digital post office. A producer, that's our main service, can just walk up, drop off a letter, and immediately walk away. It doesn't have to wait. The post office, our queue, holds on to that letter safely until the mail carrier, the consumer, is ready to come and pick it up for delivery. The sender and receiver never even have to be there at the same time. And this simple idea is incredibly powerful for a few reasons. First, it decouples our services. The sender has no idea who the receiver is, and frankly, it doesn't care. Second, reliability. If, say, the SMS service goes down for an hour, no problem. The messages just pile up safely in the queue until it comes back online. Third, scalability. If notifications are backing up, we can just add more consumers, more mail carriers, to process the work faster. And finally, fault tolerance. If the email service fails, it doesn't bring down the push notifications or the main service. Everything else keeps running smoothly. And this really gets to the heart of modern system design. As one of our sources puts it so well, in a microservices world, prefer asynchronous communication. If one of the microservices is down, that shouldn't affect other microservices. That autonomy is the goal, and it's what makes these large, complex systems resilient. Okay, so we've solved the waiting problem. Our system is fast and reliable now. But what about the next challenge? How do we take a single event, like a new friend request, and send it out to push, SMS, and email services all at once without creating another bottleneck? This is where things get really clever. The answer is a design pattern called publish-subscribe, or just pub/sub. The idea is simple. Instead of sending a message to one specific place, our publisher sends a message to a general topic, kind of like a public bulletin board. Then, any number of subscriber services can be listening to that topic, and they all get a copy of the message to work on in parallel. So check out how this fan-out actually works. Our main notification service publishes just one event. Hey, user 123 has a new message. That event gets sent to a central message topic. And instantly, every service that's subscribed gets a copy. The push service grabs it and starts its work. At the same time, the SMS service grabs it, and the email service grabs it too. One single event kicks off 3 separate parallel workflows. It is incredibly efficient.
But hold on. Blasting every channel for every user is a great way to get them to turn off notifications entirely. A good system has to respect its users. So, what if user 123 only wants push notifications and absolutely hates getting SMS alerts? This brings us to a really critical piece of the puzzle, putting our users in control.
So think about it. When our little worker services pick up that message from the queue, they can't just blindly send it out. First, they have to ask a question: does this user actually want to receive this kind of notification on this channel? And to answer that, we obviously need a place to store all those settings. This leads us to a classic system design question. Do we use a SQL or a NoSQL database? SQL databases are super structured, like a spreadsheet with strict rows and columns. That's fantastic for things like financial data. But NoSQL databases are way more flexible. You can think of a user's profile as a single document, and you can easily add new settings later on without changing everything. For user preferences, where we might want to add a new notification channel next month, that flexibility of NoSQL is a huge win. Plus, they're typically easier to scale out horizontally as our user base grows. All right, we've solved the bottleneck with message queues, we've figured out how to fan out messages to multiple channels, and we've added a way to manage user preferences. It's time. Let's put all of these pieces together and look at our final scalable system. So let's trace a request from start to finish. It all begins at the API gateway, which is like the front door to our system. It passes the request to the notification service, which is the BRAE. This service figures out what the notification is and publishes an event to our message queue, the asynchronous heart of our system. From there, our independent worker microservices for push, SMS, and email all pick up the event. And here's the key. Before they do anything, they make a quick call to the user database to check that user's preferences. If the user wants that notification, then and only then does the worker send it out. It's a clean, efficient, and super reliable flow. And what's the payoff for all this careful design work? Well, it's a system that can handle some serious volume. We're talking about the capacity to process over 10,000 notifications every single second. That's the kind of scale that powers the world's biggest apps. So, to wrap it all up, what are the big ideas we use to succeed here? It comes down to 4 core principles. We used asynchronous communication to get rid of those terrible bottlenecks. We built our system around decoupling so that each piece can be changed or updated on its own. This design allows for easy horizontal scaling. If things get slow, we just add more worker machines. And finally, we achieved fault tolerance, so a problem with one part of the system doesn't cause a total meltdown. And there you have it, from a simple, flawed idea to a robust, scalable notification system. But of course, the work is never really done. As notifications get smarter, with AI personalizing the content and machine learning predicting the perfect time to send them, what do you think is the next great system design challenge on the horizon? I'd love to hear your thoughts. Thanks for tuning in.